augments our certification process. And I'll turn it over to Benji.
Great, thank you, Steve. And it's a great question. It's kind of just playing right off from there. It's true, right? The more you fly, the more you learn. So it's just like the more you test, the more you learn. I would never be one to say we should fly less or test less. I'd rather learn everything we can. And that is a great opportunity from these Starlink flights. We get to fly our higher count flight-proven vehicles to take the Starlink satellites to orbit. And in fact, this is a good example. So the anomaly that we saw on this one particularly, it was a higher count vehicle, and some of the components were actually the highest count. They were life leaders. In this case particularly, there was an engine. To give you just a little bit more detail, basically there are covers, we call them boots, over certain parts of the engine. In this case, one of these boots, this was the highest count number of flights that this particular boot design had seen. And it's important, we do this, we know that this is happening, we're studying this, we want to make sure we understand the life process of these flight-proven components and vehicles. This particular boot had a little bit of a hole, basically, developed a hole. There's hot gases, of course, I mean that's what makes the rocket go up, very hot gases coming out of the engine, but you want those hot gases to be where they're supposed to be and not go where they're not supposed to be. So that boot, a little bit of a hole developed, a little bit of hot gas got to where it's not supposed to be, and it caused that engine to shut down. And that's the great thing about Falcon 9, is we have engine out capability. Plus the vehicle has all of these great systems to autonomously control itself, shut down, abort what it needs to, and in this case it did exactly what it was supposed to do. It cut out that engine, turned that engine off, the vehicle was safe, the vehicle got to orbit, put the satellites exactly where they want to be, primary mission was accomplished. When that booster came to return home, because of the problem with that particular engine, we didn't have enough thrust in order to get back to where we needed to be, and didn't land where we wanted to be in that case. But bottom line is that's a great lesson that we learned from from doing these multi-life, very long life leader type components and vehicles. In terms of going from there, we apply okay, well here's where we need to do more inspections. Here are the kinds of components we need to replace, and here's where we can actually upgrade the systems, right, the algorithms on the vehicle to even further detect and control what the vehicle needs to do. And that's what we're doing as we move forward.